x equals minus 4 and x equals minus 3. So my factors should actually be x plus 4, x plus 3. Now I can do that from whatever this has just given me and put it back into the equation, or I can actually find, if you go to interactive, transformation and factor, click on the factor thing. Now type in your equation, so we've got x squared plus 7x plus 12, and it should give me x plus 4, x plus 3. So it's factorizing that, and there you go, x plus 4, x plus 3. So that finds the factors. So I'll just have a look, let's see what's some examples that so from chapter 4 we might need okay, 4.4, let's see, factorize and then sketch the graph. So one of them is 9x squared take 3x cubed plus x take 3. Okay, so this is 4.4, question 14c. So we want to factorize this first. Interactive, transformation, factor. Now you just need to click factor, and there you go. There's the factors. Okay, really quick and easy, and you'll be able to use that to check your answer. Now sometimes with negatives especially, it might look a little bit different in there than what we would do on when we work it out by hand. So sometimes you might have 3 take x, for example, in there, and that's because the negative's been put out the front. Okay, so that's factorizing. Now we can also go the other way around. So let's say we've got this equation here, and it's asking us to expand the brackets. Alright, we can do that by hand if we want, but there's actually a quicker way if we want to use the calculator. Again, it's good to use your calculator to check your answers, so try doing it by hand and then check your answers on your calculator. Transformation, and here we go, expand. So expression, if we highlighted it, that's what it's going to give us. So just click OK, and we should get the same answer as what we had up here. So there you go. They've just rearranged it, so we've got x cubed at the front. Up here we had x squared at the front. So that's okay, it's just in a different way. Now, there's also what's called simplify here. Now, we might be x squared plus 4x squared plus 8x squared plus 6x cubed. And what happens when we... yep, okay. That's alright. Let's change that to a 5. Okay, so we get 6x cubed plus 14x squared. Now I can actually simplify it even further, hopefully, if we click simplify. And there you go, so it's taking out a factor of 2x squared, because 2x squared goes into both that and that. So when you type that in, you get this. Okay, we can actually simplify it even further, and a calculator can do that for us, and that's there. So some really cool functions in transformation, and also advanced we can solve. So if I wanted to solve that when that equals 0, okay, highlight it, and I'm doing it a different way to what I did before. So solve, where I had answer, well, I can just highlight it. It does the same thing for me. There we go, so x equals 0 and x equals minus 7/3. So have a play around with that. Again, use your calculator to check your answers is generally your best bet. We don't want to be using 100% our calculator because it is math methods. We want to know how to use the methods. So we're learning what the calculator is doing, I guess, in a way. Now graphing, we can graph equations. So if we go to menu, when it loads, and graph and table. So I've already got one in there as 3x4 plus 5x, take 5x cubed, take 5x squared. Okay, not sure what the example that's for, but let's have a look what happens. So we can type it in, click enter, and you should have a little tick next to the y. Okay, so make sure that's ticked. And then click this little button here, and that will graph the equation for us. So there you go. So click resize, and that's what that equation is. So it's a quartic, and that's the equation. So we can find some points on here. So when you graph your equation, if you go to analysis and go to gsolve, so there's some really cool things here. First we can find the roots, so that's our x-intercepts. So first one at -1, 0. And if we click the arrow on our keyboard, it should go across to this one, so it's -0.33 recurring. Okay, so likely -1/3. And next part will be at 1, so there you go. And go across again at 2. So there, the x-intercepts for that equation, and that's just found by clicking analysis, gsolve, and root. Now, if you notice, we've got minimum, maximum, fmin, fmaximum, y-intercept. Let's click on y-intercept. And it should tell us that's 2. Okay, so the equation gives me a y-intercept of 2. Now, f maximum means the maximum point for the function. Now, for this one, if I go out, it goes all the way up on either side. No, get out of that. Okay, so it goes up in the y direction, up basically into positive infinity. Now, so I don't want to use f maximum because f maximum finds the maximum point for the graph goes. But I can find the maximum turning point by just clicking max. And that'll give us the maximum turning point, hopefully. Yep, there we go. So maximum turning point, okay, not a very nice number, but that's what the x-coordinate is in here. And then the y-coordinate for that is in here as well. Not very nice. And similar thing for the minimum, so you can find the minimum values, minimum turning points, I should say. So when it works out at -0.718, and if we go across, because there's 2 minimum points, there's the next one. Okay, so some really cool things on the graphs and stats when we're drawing graphs. And if I go back, so click on this to get back into this, I can actually draw a couple of graphs on the same axes. So let's say I want to draw that graph and find the intercept of what happens at x. I'll say a linear graph, so 4x plus 8 for example. Okay, make sure it's ticked and then click the graph. So there's the blue one, that's my quartic, and that red one is the straight line. Now I can actually find the intercept of those 2 points by clicking on interception. And there you go. So intercepts at both the equations at -1.18 and 3.26. And then the next point it intercepts at is here at 2.43 and 17.7. Okay, so some really cool things that you can find from that. There's a point of inflection, so if you've got a cubic, you can find the point of inflection. It should tell me not found on this.